Welcome, fellow space enthusiasts. Today, we're embarking on an incredible journey to uncover the secrets of Jupiter, the largest planet in our solar system. Jupiter's immense size, unique structure, and fascinating atmospheric dynamics have captivated scientists and astronomers for centuries. In this video, we'll delve deep into the giant planet's characteristics, exploring everything from its massive dimensions to its mysterious core. So, fasten your seatbelts as we set off on an adventure through the wonders of Jupiter. Jupiter is a true giant among the planets. It has a diameter of about 142,984 kilometers, 88,846 miles, which is more than 11 times the diameter of Earth. This makes Jupiter so large that all other planets in the solar system could fit inside it with room to spare. In terms of volume, you could fit about 1,300 Earths inside Jupiter. Its mass is equally impressive, as it is more than 300 times the mass of Earth, making up nearly 3/4 of the total planetary mass of the solar system. This immense size means that Jupiter exerts a tremendous gravitational pull, influencing not only its own moons, but also the asteroid belt and the orbits of other planets to some extent. Jupiter's massive presence in the solar system acts as a kind of cosmic vacuum cleaner, pulling in comets and asteroids that might otherwise threaten Earth and the inner planets. Jupiter's composition is primarily hydrogen and helium, much like the Sun. In fact, if Jupiter had been about 80 times more massive, it could have become a star rather than a planet. Its atmosphere is composed of about 90% hydrogen and 10% helium by volume, with trace amounts of other elements such as methane, ammonia, and water vapor. Atmosphere. Jupiter's atmosphere is a dynamic and turbulent place. The planet's rapid rotation, completing a spin every 10 hours, creates strong jet streams that run east-west, resulting in the distinctive banded appearance of its clouds. These bands are composed of ammonia clouds at different altitudes, with the lighter-colored zones consisting of rising air and the darker belts made of descending air. The upper atmosphere of Jupiter is divided into several layers. Troposphere. This is the lowest layer, where most of the weather occurs, including the formation of clouds and storms. Stratosphere. Above the troposphere, the stratosphere contains a layer of haze particles. Thermosphere. This layer is characterized by high temperatures due to the absorption of solar radiation. Exosphere. The outermost layer, where atmospheric particles are so sparse that they can escape into space. Interior structure. Jupiter's internal structure is quite different from that of Earth and other terrestrial planets. Beneath its thick atmosphere lies a layer of liquid metallic hydrogen, a phase of hydrogen that exists under the extreme pressures and temperatures found within Jupiter. This metallic hydrogen is an excellent conductor of electricity and is responsible for Jupiter's powerful magnetic field. Scientists believe that Jupiter has a core composed of heavier elements, though its exact nature is still a subject of research. The core is thought to be surrounded by a layer of metallic hydrogen, which in turn is enveloped by a layer of molecular hydrogen. The transitions between these layers are gradual rather than distinct boundaries, due to the extreme pressures and temperatures within the planet. One of the most striking features of Jupiter is the Great Red Spot, a gigantic storm that has been raging for at least 400 years. This anticyclonic storm is larger than Earth and exhibits wind speeds of up to 432 kilometers per hour, 268 miles per hour. The Great Red Spot is a high-pressure region in Jupiter's atmosphere, with cloud tops extending higher and deeper than the surrounding areas. In addition to the Great Red Spot, Jupiter's atmosphere is home to numerous other storms and vortices. These include smaller red spots, white ovals, and brown barges, all contributing to the planet's dynamic and ever-changing appearance. The interaction between these storms and the planet's jet streams creates a mesmerizing and complex system of atmospheric motion. Jupiter's magnetic field is the strongest of any planet in the solar system, extending up to 7 million kilometers, 4.3 million miles, towards the Sun and almost reaching the orbit of Saturn on the opposite side. This powerful magnetosphere traps charged particles and creates intense radiation belts, posing significant challenges for spacecraft. The magnetic field is generated by the movement of metallic hydrogen inside Jupiter. This field interacts with the planet's moons, particularly Io, which orbits within the magnetosphere and contributes material to it through its volcanic activity. The volcanic eruptions on Io release sulfur dioxide gas, which gets ionized and forms a plasma torus around Jupiter. While Saturn is famous for its bright and prominent rings, Jupiter also has a ring system, though it is much fainter and composed primarily of dust particles. Jupiter's rings were first discovered by the Voyager spacecraft in 1979 and consist of three main components: the halo ring, the main ring, and the gossamer rings. Halo ring, a thick, donut-shaped ring of particles extending vertically above and below Jupiter's equator. Main ring, a relatively narrow and thin ring made up of small, dark particles. Gossamer rings, two wide, faint rings made of microscopic debris from Jupiter's small moons, Amalthea and Phoebe. These rings are maintained by the continuous impacts of micrometeorites on Jupiter's inner moons, which eject dust into orbit around the planet. Jupiter is a planet of superlatives, from its immense size and powerful magnetic field to its dynamic atmosphere and complex ring system. Our understanding of Jupiter has been greatly enhanced by the Voyager missions, the Galileo orbiter, and more recently, the Juno spacecraft. Each mission has provided new insights into the planet's structure, composition, and the fascinating phenomena that occur within its atmosphere and magnetosphere. As we continue to explore Jupiter and its many mysteries, we gain a deeper appreciation for the complexity and beauty of our solar system. Thank you for joining us on this journey through the wonders of Jupiter. If you enjoyed this video, don't forget to like, comment, and subscribe for more exciting content about our universe. Stay curious and keep exploring.